Okay, IBAASL1. Today we're not necessarily learning anything new. We're just kind of doing a bunch of examples that involve all the relatively new derivative rules that we've learned and combining everything. So with all these first examples, the directions are going to be to differentiate, which means take the derivative, and find the slope of the tangent line at the given x. Let's not forget everything we've learned so far, which is that a derivative is just a tangent machine. So if you take a derivative and plug an x into it, you're going to get a slope of a tangent line. First step. When I look at this, there's no chain rule, there's no product, there's nothing, there's none of those special like, quotient or anything like that. It's pretty straightforward. We just have to do the derivative of e to the x and the derivative of ln x. Remember the coefficients can just hang out front. You don't really need to do anything with those. So y prime, 4e to the x, the derivative is just 4e to the x. Remember, e to the x is the freebie. Now, ln of x is 1 over x, so you get minus 2, 1 over x. I do want to rewrite this a little bit and say y prime is 4e to the x minus 2 over x. Remember, you can squish those fractions together. Now, that's the slope machine, and we want to know the slope of the tangent at x equals 1, so we're just going to plug in 1 for x. So, you can't really simplify this too much other than just say 4e minus 2. So this is the slope. All right, that one's fairly straightforward. The next one, sine and cosine. Also, we're going to plug in an x equals pi over 3. Get out your unit circles, guys. Actually, JK, don't, because all you really have to do is do like a right triangle in a circle, which I'll show you how to do in this problem. So, first step, differentiate. Derivative of sine is cosine, so that becomes 3 cosine x, and the derivative of cosine is negative sine of x. So then we get y prime equals 3 cos x plus sine of x. Now we're going to plug in the pi over 3. So we get 3 cosine pi over 3 plus sine pi over 3. Now, if you don't know what cosine and sine of pi over 3 are, here's how I do it in my head. I draw a unit circle every time I need to figure out something like this. Look at that perfect circle that I drew. Amazing. Now, pi over 3 is the same thing as 60 degrees. That is something that I remember. Pi over 3 is the same thing as 60 degrees, and pi over 6 is the same thing as 30 degrees. So, if I fit a 60-degree angle here into the first quadrant, this is a 30, 60, 90, where this is 60, this is 30. The hypotenuse is always 1, and across from the 60 is root 3 over 2, and next to the 60 is the 1/2, or across from the 30 is the 1/2. Now, this is the bases of your triangles are your cosine values. This is cosine of theta, and this is sine of theta. So now getting back to my problem, I can see that the cosine is 1/2. So this becomes y prime equals 3 times 1/2, and then the sine is root 3 over 2. So this is 3/2 plus root 3 over 2. They already have a common denominator. Score. I don't like that one. There's your final answer. Oh, yeah, no, that is the slope. It's just a funny slope, 3 plus root 3 over 2. Show that the slope of the tangent to y equals 4e to the x minus 7 at x equals ln 3 is 12. So I can already see this is going to bring up some logarithm knowledge, so I'll kind of walk you guys through that. The derivative is pretty easy. It's just 4e to the x. Remember that the minus 7 part goes away because the derivative of just a constant or a number is 0. Now I need to plug in ln of 3. So that goes in the x spot. Now, there's a property of logs where if, how do I say this? if you have like a log base a of x, this is equal to just x. The thing that matters most is that the base here matches this big base right here. So then you can kind of get rid of those bases and say that x equals x. What's happening over here, don't forget that natural log is the same thing as log base e of x. So these parts actually cancel each other out, and we just get y prime is equal to, oh, sorry, no, natural log of 3. I was off the rails for a while there. This should have been a 3. So then when you cancel out, this is 4 times 3, which is 12. So we proved that 12 is the slope. Just had to remember a little bit of log knowledge. Find the slope of the tangent to the curve. Okay, you guys, when I look at this, I see a function nested inside of a function, which means we have to do chain rule. Remember, chain rule is derivative of the outside with the inside the same. So the derivative of the outside is just e to the something, which the derivative of e to the something is still e to the something. So that's x squared minus 2x. But then the rest of chain rule is times the derivative of the inside. So we have to multiply this with 2x minus 2. That's the derivative of x squared minus 2x. Now, that is the derivative. That's the slope machine. So really, we can just plug in a 2 and try to simplify. So y prime equals e to the 2 squared minus 2 times 2 times 2 times 2 minus 2. It's too many 2's, you guys. E to the 4 minus, oh, this is e to the 0 times 4 minus 2, which is 2. Well, remember, anything to the 0 power is just 1. So this equals 2. That's the slope of the tangent. Excuse me. Find the equation of the tangent. So the equation of the tangent is going to be a y equals mx plus b. Now, before we plug in to find the derivative and stuff, I'm going to take the x equals 0 and plug it into the original function to figure out what point the tangent is going to pass through. Three times 0 is 0, so we get y is equal to the natural log of 1. So you might not remember it, but you can simplify natural log of 1. Allow me to explain with a little sidebar about what the natural log of 1 is. Natural log of 1, if you don't know what this is equal to, you can always change the natural log back into log base e of x is equal to something. Now, there's a property of logs where you can change a logarithmic into an exponential, and the way you do it is by spiraling. Here's how you spiral. You start with the base, then you hop over to the other side, to the power, and then you bring it back over the equal sign. So this is e to the question mark is equal to x. Oh, sorry, that shouldn't be x, that should be 1. So the exponential form of this is e to the what gives me 1. Well, you guys, if you raise something to a power and get 1, the only way you can do that is if the question mark was 0. So this whole thing is 0. So back to my derivative over here, y is equal to, no, sorry, I said derivative, I meant it's the OG equation. I'm finding the coordinate that it passes through. When I put in a 0, I got out of a 0. So 0, 0 is the point the tangent passes through. Now, I haven't done anything with the derivative yet, so let's take the derivative of that function. When I look at the OG function, I see a chain rule because there's a function nested inside of a function. So the chain rule is derivative of the outside, which natural log is 1 over x, but with the inside the same, untouched, So that's 1 over 1 minus 3x. And then times the derivative of the inside, which is just negative 3. The only way to clean that up is to say y prime is equal to negative 3 over 1 minus 3x. Remember, you cannot cancel out these negative 3's. Canceling doesn't work like that because these are glued together through subtraction. Now, that's the slope machine. Let's go ahead and plug a 0 into it to see what the slope is. Because 0 was the coordinate, the x part of the coordinate that it goes through. If you simplify that, you get negative 3. So that means y equals negative 3x plus b. Then I have to plug in my point to figure out what the b value is, but they're both 0, so that works out nicely. So 0 is equal to b, and then my final equation is y is equal to negative 3x plus 0, but we can just leave it as y equals negative 3x. Last problem, find the slope of the tangent of that at x equals 1. You guys, when I look at this, I see a product rule. So product rule is first d second plus second d first. All right, let's do a little cleanup. The second part, I just moved the 3x squared in front of it to be more like a coefficient. You can cancel out an x right here, so this becomes x squared plus 3x squared ln x. Yeah, let's go ahead and plug in 1 to the slope machine because we're finding the slope of the tangent. So f prime of 1 is equal to 1 squared plus 3 times 1 squared ln 1. 1 squared is just 1, 3 times 1 is 3. But remember that ln to ln of 1 is like e to the something equals 1. So that's a big 0. So this whole chunk here becomes a 0. So that's the slope. All right, you guys, that's all I got for you today. Good luck.